So in this session, we'll see what are the different what-if analyses that we can perform once that we have built our model and calculated our net present value and internal rate of return. So let's look at this model. Here you find the calculation of the net present value and an ARR. So you find the plan of the expected cash flows of this project for 5 years, and you get a basic NPV of 5,026 with a weighted average cost of capital 12% and an ARR of 24%. So given the first analysis, the project seems to be convenient, but here the main problem we have to address at this point is what happens if we change the original assumptions and what are the boundary conditions under which the project is still convenient. So Excel gives us the opportunity of performing 3 different types of analysis in a very simple way. So if you go in the data section and then you open the what if analysis, you find 3 different functions that are scenario manager, goal seek, and data table. Let's start from the first one, that is goal seek, and let's try to answer a very first simple problem, that is what is the break-even level of the critical variables. That is basically asking what are the values of the main parameter that makes the NPV equal to 0. So that, for example, you could ask what is the minimum price at which we can sell the product in order to get a positive NPV, or ask what is the maximum per unit cost that we can afford in order to have a positive NPV. So let's work on the first case. So let's see what is the minimum price at which we can sell this product in order to have still a positive NPV. So if we go to the assumption section, we can see that the price of each unit sold has been originally fixed to 260. So now we can try to answer the following question. What is the minimum price at which we can sell the product to still have a positive NPV? So going in the what if section of Excel, we can select the function goal seek and basically set the cell where we have the net present value that is being calculated here to 0, so that we are fixing basically the break-even value by changing the cell of our interest, that in this case is the cell where we find the original assumption about the price. We give the OK to Excel, and Excel is automatically calculating the break-even price, that is the minimum price at which we can sell the product in order to still have a positive NPV. So in fact, if you then we look at the net present value is equal to 0. So this means that until the price is higher than 232 per unit, the NPV will be positive. If it's lower than this value, the NPV will be negative. So this is our break-even value in the model. So let's go back to the previous value, and we now can try to answer a more complex question. So one of the problems with break-even analysis is that it's just taking one value at a time, and moreover it's just considering the break-even value. For example, I could be interested instead in seeing how the NPV changes when 2 variables change at the same time, and moreover I could be interested in understanding what is the NPV associated with each of the possible values of the 2 variables. So in order to answer this question, we can use another function of Excel that you find in the what if analysis section, that is the data table. So here in the Excel file you will find a table that is predefined in this case, where we have set in a discretional way the potential intervals of the price and the per unit cost. So this table is assuming that the price can vary between 220 and 280, and that the per unit cost can vary between 90 and 130. So let's see now what we need to do in order to build the table that we want to create. First of all, taking this table, we have to recall in the upper left corner the function that you want to change in the table, that in our case is the function where we have calculated the net present value. Okay, so once that we have recalled this function here, we can select the whole area here and go in what if analysis data table. At this point, Excel will ask us what cell is changing on the row, what cell is changing on the column. So as we have said before, on the row we'll have the price changing, whereas on the column the variable that will change will be the per unit cost. So once that we provide this information to Excel and we give OK, we go back to our table, and then in the table we find the different values of the net present value associated with each couple of values of the price and the premium cost. So you see that with very few steps you have built a complete sensitivity analysis that shows how the net present value changes with the joint changes of two main variables that you consider in the analysis. Now the last problem is the following. Let's assume for a moment that you don't have two main variables, but you have more than two variables changing at the time, and you want to see how the net present value change with these two or more variables. In this case, you can use another function of Excel that is the scenario management. So you always go to what if analysis, and at this point you can define different scenarios where you have more variables changing. So let's assume that at this point you want to define two different possible scenarios that are the scenario that we define as best case and worst case. That basically means that you want to understand what is the NPV in the case of the best case scenario, where all works out in the best possible way, and you want to see also the NPV in the worst case, that is the case where you assume the worst assumption. Let's assume that the three variables of interest are the per unit cost, the price at this time, also the weighted average cost of capital. So you go to the scenario management function, you start adding a new scenario. Let's start from the scenario that you define as best case, and then you pick the cells you're interested in. And these are the price, the per unit cost, and the weighted average cost of capital that is here. So once that we have inserted the three variables of interest, we can set the value in this particular scenario. So let's remember that this is the best case scenario. So here we have the best assumptions that we can hypothesize for this project. So for the price, we can put 280. For the per unit cost, we can assume that it's 90. And for the weighted average cost of capital, we can assume that it's 10%. Okay, and so in this way we define the first scenario. Now we go to define the second scenario that we call worst case. Excel is already recognizing the three cells we want to use for the scenario. We give the OK. In this case, we have the worst assumption. So let's assume that the price will be 220. The per unit cost will be 130. And with the average cost of capital will be 14%. We give the OK, and so at this point we can ask Excel to provide a summary of the two scenarios, and where the result cell is the NPV, that is what we are interested in. We give the OK, and Excel is now providing a new table where it's showing how the NPV changes in the two scenarios. So here you can see the assumption that we have in the best case, where the price was 80, the per unit cost was 90, the weighted average cost of capital was 10%. In this case, in the best possible scenario, we get a net present value of 13,698. If we go to the worst case, we see that the assumption where the price was 220, the per unit cost 130, and the cost of capital 14%. In this case, we got a strongly negative NPV that is 6,450. So this is the most negative NPV we can get from this project. So as you can see, performing these different types of what-if analysis, we have reached a better understanding on the project. So we don't just say the NPV is positive or negative, but we better understand the conditions under which NPV is positive, what are the risks that the firm is taking by investing in this project, and we are able to identify the main variables that can affect the value of the project, and we can understand how these variables affect the final result.